You probably must have heard of the term gravity. All right, and then you're trying to wrap your head around what exactly gravity is. Well, it's simple. It is the pull of a massive object. When a massive object produces a field that pulls another object towards itself. That's what gravity simply means in layman's terms. Right. So we've got two types of forces. We have the contact force, where you've got your friction, your air resistance, and all of that. And then we've got the non-contact force, where you've got your magnetism, your gravitation, your electrostatic. So we're talking about gravity right here. And then, humans have had explorations in space for quite some time now. So humans have seen and experienced firsthand what gravity does. For example, objects drop down from the sky. There's a force of gravity, and then you have the tide. So in terms of the moon and the earth, the moon pulls on the earth. That's why you have the tidal waves and all of that. And then the earth pulls on the moon. That's the reason why the moon could keep on rotating, or let's say revolving around the earth in a 28-day cycle. All right, now that is a question of the relationship between the mass of an object and the force of gravity. And what we can establish today is that the bigger the mass of an object, so the bigger the force of gravity that acts on it, and vice versa. The smaller the mass of an object, the smaller the surface gravity. All right, now the force of gravity, that's a direct proportion. Second relationship, the force of gravity is inversely proportional to the square of the distance between the two objects in question. All right, so we'll see all of that play out in one or two questions that we're going to solve in a moment. So you stick around for that. Now we've got the universal gravitational constant, which is G. That's 6.67 times 10 to the minus 11. You've got that on the screen. The law, Newton's law of gravitation here, states that gravitational force of attraction between 2 point masses m1 and m2, separated by a distance r, is given by F equals G m1 m2 over r2. So F is directly proportional to m1 and m2, as you can see on the side of the screen, and then it's inversely proportional to r squared. Now direct proportion means as value A increases, that's as F increases, or let's say as M increases, whether M1 or M2, F also increases. Same direction, positive correlation. And then inverse proportion means that as F, or let's put it the other way around, as R increases, that's the distance between the two objects increases, the force of attraction reduces. That means the closer you are to that mass in question, the stronger the force of gravity. Keep that in mind. So I have a question here saying that you should calculate the gravitational force between the sun and Halley's comet, and then you've got the distance given to you. So what you just do, you use the universal law of gravitation we looked at earlier. You have your m1 as 2 times 10 to the 30. You have your m2 as 3 times 10 to the 14, and then you've got your r, 5 times 10 to the 12. Plugging in with a G is a constant. It's always given to you in your data booklet or whatever it is you're working with. Punch that into your calculator, you get 2 times 10 to the 9 newtons versus measured in newtons. All right, that is to one significant figure. A second one, calculate the gravitational attraction between you. You've got a mass of 65 kg and the Earth, it has a mass of around 6.0 times 10 to the 27. So we take that as m1 and then your mass as m2. We have the distance as 6,400. You convert that to meters, that was 6.4 times 10 to the 6. All right, you multiply that by 1,000. And then you have your G is 6.67 times 10 to the minus 11. Plug that into your calculator, you get the same figure. All right, so thank you for sticking around, and I'll see you in the next video.